We are given a root of the tree and also two random nodes of that tree. We need to find out the lowest common ancestor of these two random nodes. For example, if p equal to 5 and q equal to 1 are the two nodes given, then the node 3 will be the lowest ancestor common to both these nodes 5 and 1. An important thing to note here is that a node can be an ancestor of itself. That is, if p equal to 5 and q equal to 7 are the nodes, in that case, the node 5 will be the lowest common ancestor of both 5 and 7. To find out the lowest common ancestor, what we can do is run a DFS. We are required to find two nodes p and q. So let's look at different scenarios of occurrences of these two nodes. The first scenario is we found one node on the left subtree and the other one on the right subtree. In this case, we have found out a total of two nodes at the current node, and therefore the current node will be the lowest common ancestor of those two nodes. The second scenario is we found one node on the current node itself and the other node on the left subtree. In this case, we have found a total of two nodes at the current node, and therefore the current node will be the lowest common ancestor of those two nodes. The third scenario is we found one node on the current node itself and another node on the right subtree. In this case also, we have found a total of two nodes at the current node, and therefore the lowest common ancestor of those two nodes is the current node. In all the three scenarios, the nearest node at which we are getting a total of two found out nodes is the lowest common ancestor. So based on this observation, let's take an example and solve the problem. In this example, p is 5 and q is 1. We found 0 required nodes at 6, 7, 4 and 2. So let's return the result to the respective parent nodes. At node 5, we have found one required node. On continuing the traversal, we have found one more required node. So at node 3, we have found a total of two required nodes. So this is the lowest common ancestor. Now let's take another example. Here p is 5 and q is 4. This is the lowest common ancestor. Now let's code the solution. Let's have a variable initially set to none for storing the result, and at last we will be returning it. We will write a separate function for traversing through each nodes recursively. We will start the function call with the root node of the tree. We will recursively traverse through the left and right nodes in the beginning. In this function, we need to check whether the current node is one of the node we are looking for. If yes, then we will set this variable to 1, else 0. We will then check whether the total number of nodes found out at this current node is equal to 2. If yes, that means we have found out the lowest common ancestor, and hence we will be storing the result in this variable. Since we are accessing an outer variable from this function, we must specify it using the non-local keyword. So at last, if we have found any node from the left, right or the current node, we will be returning 1 to the current node's parent. If nothing found, then we will be returning 0 to the current node's parent node. Also, we need to put some checks at the beginning of the function. If we have reached the end of the tree or if we have already found out the result, then we need not continue the recursion and we can return 0. Let's try running the program. It's working. See you in the next video.